And these connections are exactly the same as on the old V controllers. So you've got existing site. You unplug the connection to the 6-way, another 6-way, and you can plug it straight exactly as it was, or how it was connected on the V series. You plug it straight in the same way. There's your master slave sense or decoder cables, and here's your master slave and battery cables, or battery cable and your master slave motor power cables. This 10-way connector, this is where the change is actually when it comes to connections, because now we've got, instead of a trigger connection, we've got an IO1 to IO6. When the old vantage, we've got trigger, pedestrian, solenoid, courtesy light, and all that. Now you can determine in programming how you want this to be done. So that's why these if the client had external receivers connected to the old vantage, this you would have to reconnect or reconnect into different slots from the old one. But on the other connectors, it's a straight swap over. Okay. Right, so let's have a look. There's your controllers, connections. There's 2 fuses for both the motors. Then you've got your charger input with the normal CP84SM charger. And we've got a little LED, which is also a push button. Okay, and then we've got an earth connector. And obviously the built-in receiver. You'll see the little cable coming out here on the controller. So let's have a look at the description for the connections. Like I said, this is a 6-way connection for your slave sensor 1 and sensor 2 cable, your master, the M stands for master, sensor 1 and sensor 2, and your positive negative for the sensors. So it's always sensor 1 is purple and sensor 2 is blue. So it's purple blue. If you only have one motor, that means you've only got a master. So there will be a master. This will be your purple cable on this vector cable that you'll get. There will be a purple cable, a blue, a red, a black, and then a thicker blue and black cable. But they are thicker because that's the power cable for the motor. So the purple, the thin purple wire will go into sense 1. The thin blue one will go into sense 2 if you've got a master motor. The same will be on the slave motor on its own cable. And then a positive negative on both master and slave will go into positive red, thin cable, and thin black cable on negative. Okay.
So tell me the concept of master and
slave.
Yeah.
So the master is always the motor. If you've got a single motor, it's only one gate. It's one swing motor. Then that will always be the master. So you put that, this motor, you connect it to the master connector.
Yeah.
Should you have a double swing motor, a double gate, so then you need to add another motor, same motor. So it's not that you buy a master and you buy a slave motor.
Yeah.
Where you connect this one, that makes it a master or slave. So it's like you can't, there's a vantage 400, vantage 500. There's not vantage 400 slave, vantage 400 master. There's only one motor between the two sizes. You make it a slave or you make it a master.
Okay. And this sleeve and the master are on the same leaf.
No, different leaf. So this is a leaf, and this is another leaf. So yes, like this. So the left hand side, so if I'm inside my property, I'm looking towards the street. Yeah. Then I would normally put my control on the left hand side, but maybe I can't because maybe there's power on the right side.
Yeah.
So normally we make the master motor the closest to your controller, but it doesn't have to be like that.
Yeah.
It could be totally other way around. Depends on now if you go mag lock, depends on where you put your mag lock. So it all depends on how you install it.
Okay.
So you can make your master motor the left one or the master motor the right leaf. It doesn't matter. It's up to you how you want to configure. Because only one thing that you need to know, if you've got double leaf motors, the master is always the first one to open, and then the slave, and it's always the last one to close. So that's important when you start getting into mag locks and stuff like that. You've got to make sure that the master is always the one that needs to open first, then the other one can come, and the other one the slave needs to close first, and then the master close on top of it, if you've got a mag lock or a gate lock. So the master is only the one to move first and stop last, if I can say that. Then that will determine which one you can make master.
No.
Because sometimes people will put they will weld a flat bar on one side of the leaves of the gate. So that means that one's got to be the one that closes first and opens first.
Yes.
So that will determine which one's going to be the master. So you just got to know the master is always the one that moves first and stops last.
Yes.
First out and last to close. Then that will determine which one's going to be the master.
Okay. Now, in a case where you have a configuration that you have two motors
Yes.
on the same leaf,
Yes. Okay.
and then you've got 4 of these
Yes.
motors,
Yes.
how do you work it out in terms of master and slave?
So then the one leaf that's got two motors, that will be the master side example, and the other leaf will be the slave side.
Yes, yes.
But now the second motor on the master, the second master, doesn't become a master. It becomes just, it only gets power. You don't connect the purple and the blue and the red and black wire on the sensor cable. You just connect the thicker blue and the thicker black, black and blue cable on the power of the master.
Okay.
The second one.
The second one. So if you're on the master leaf, the second motor on that master leaf only gets power, only gets the thick blue and the thick black. The sensor cable, you don't connect it. Because that's just going to be a dummy. It just gets power because the control will tell the master, okay, master, move. The master that's connected with the sensor will give the count and say, okay, I'm counting, this is the opening. So the second motor that's on the master leaf will just be purely a dummy, will just get power, and then, so it's got no intelligence basically. Because the other motor that it's working with will give the count to the controller.
Just like following for the first one.
Yeah, we'll follow the first one, yes, yeah.
So practically you always have one master.
Yes, one slave. Yes.
And the other two motors are just accompanying and they get power.
They just get power. They are
Okay.
purely dummies. They just get power. They don't count any DOS sensor.
Yes.
They just get power and say, okay, I'm moving.
Yeah.
They don't count. They're not giving feedback to the controller saying this is where I am at the moment. Because it's relying on the master that's got the sensor cable to tell it the controller where to stop.
Okay.
So they're all connected to the one panel.
Yes.
Yeah.
Yeah. So two motors on one leaf. The one will be a master that's truly a master that's got the sensor cable. The second motor on that same leaf will purely be paralleled with the master power
Which is
cables, positive, negative, to give it power. But it's got no intelligence to it. Okay. So in drawings, I will show you how to do it. So there is the slave, sense 1, which is the purple cable, goes to slave, S for slave, sense 1. The slave 2 will be a blue cable, that will go to sense 2. Then you have a master cable, or master motor, so master 1 will be another purple cable, and the master 2 will be the sensor 2. Or the master operator sensor cable will be purple. So it's purple blue if you've got a slave motor, and purple blue if you've got a master motor. Well, you will definitely have a master motor. You always have a master motor. You must always connect if you've got one motor, that will be the master motor. And then obviously both the slave motor and both the master motor, small little red wire, you'll connect it to positive or sensor positive, and the small little thin black wire, you'll connect it to sense negative. So if you've got a master motor, that you've got two motors on one leaf. So you've got now 4 motors. You've got 2 masters and you've got 2 slaves. The second motor that's connected to the master, you won't connect the purple and blue. You won't connect the red, black, purple and blue on that second motor on that master slave. You can just connect it onto power of the master. The same with the slave. The second slave motor, you won't connect the purple, blue, and you won't connect the red and black. Because they will just be dummies following the controller giving power to its positive, negative on the motor wire. No, this is the DOS sensor. This is the counting side. We don't want that second motor to count because it doesn't need to rely on, because there is one motor that's already counting for it. Alright, these are the connections. Then on the motor cable, on the power cable side, this is your battery terminals, positive, negative, which is just this cable over here. And then you've got your master positive and master negative, and you've got your slave positive and slave negative. And this is where that second motor just goes into parallel. 2 blues and 2 black if you've got 2 masters, and 2 blues and 2 black if you've got slave motor. So that's the only time where the slave motor gets connected, or that second motor on that master leaf or on the slave leaf gets connected to the motor. Okay, so it's got no intelligence to it because it hasn't got those DOS connectors or that sense cables connected. Okay, any questions regarding connecting the motors? So it's purple, blue, and then obviously your power.
Yeah.
Okay.
Yeah, good.
All right.
Can you recap
Yes. On which one? The sensor or the power cables?
the question which was raised by?
Okay, so this is this one. So let's forget there's only one motor per leaf. It's one master, one slave. Okay, let's keep it simple for now. It's like this. It's one motor per leaf. So you'll have a master motor, purple blue, to master sense 2, so it's purple blue. You've got another motor on the second leaf. You've got a slave motor, again purple blue, and then the red and black you connect. That's normal installations. Should you have, we need to put two motors on one leaf. Then you say, okay, my second motor, I ignore this totally. I've done the master and I've done the slave. That is fine. They are the ones that does all the thinking for me. That second motor on that leaf is purely for extra strength. So it doesn't need to have intelligence. So I'm not going to connect that purple, blue, and red and black, the smaller one. I'm not connecting it onto the sensor. I'm just not connecting it. But I will connect the black and blue on the power on this one over here. So the second motor on that same leaf will just get a blue for positive and a black for negative on the master side. And if you've got obviously a slave side, you'll only the thicker blue and the thicker black you'll put on this connection. This is the only place where we will connect the second motor on that same leaf as the master or as the slave. Just to get power. Of course, the controller gives power to this motor and say, okay, open, and it flips it, inverts the DC, and then it reverses the motor. So this motor just gets power from the controller. The controller gives power to the motor, and then it says, okay, open or close. So there's no intelligence here, because the intelligence comes from the sensor cable. So the controller says, okay, I see you turning. Okay, stop slowing down, stop. That's where intelligence comes in. The second motor will just rely on what power it's getting out of here. Okay?
Just another question here.
Yes.
The cable that's coming out of the motor.
Yes.
That cable.
Yeah.
Which terminals are those ones?
These ones. The top one, and there's the blue and black on the bottom. So it's these cables here. So this cable, it's got six cables in it. It's got a thick blue and a thick black. Then it's got purple, a blue, which is thin, and a red and black that is thin. So it's the top one. So if you look at this controller, there's those connections over there.
So that cable, it's only the sensors that are there.
Yes, sensor on the slave, sensor on the master, and then positive negative for the DOS sensor. And then in the bottom here, you'll have your positive negative for the motor. That this is what providing the motors to turn the DC motor in it, so to make it work. But the controller needs the sensor cables to tell it where it is, and if it's open or is it closed, or where is its speed and stuff like that.
Yeah.
So the sensor cables is the DOS sensor. It needs the intelligence from the motor to tell, the motor's telling the controller, this is where I am, this is my speed, I'm approaching my full opening angle. So start slowing down, start reducing the power to this motor, so I can start slowing down and then stop. And stop at this point. I'm here, so stop. Otherwise I'm going to push through. So this is an output. The controller gives power to the motors to say open or close, or start moving fast or slower. But the DOS sensor is giving feedback to the controller, indicating where it is at that moment. I'm closed, or I'm opening up, this is my speed, start reducing speed, I'm approaching my total open distance. So start reducing the power so I can move slower and I can stop at a specific point.
So here what I see, it's a master sensor 1, master sensor 2. Right?
Yeah, it's slave and then master, yes, yeah.
Those will be connected for a particular motor.
For one of the motors, yes.
One of the motors.
Yes, yeah.
That's
Well,
what-
master one leaf and the slave on the other side.
Yeah, so you can't have from the same motor the S's and the M's connected?
No, not on the same.
All right, that makes sense. Then you have the plus and the minus. So the 4 cables are used. Whether this was
Yes.
a master or this was a
Yes,
slave, right?
yes.
Now the other 2 cables, they coming at the bottom here. In that
Yeah,
same
only
cable.
the thick cable, the blue and the black one. On the other, the second motor on that master will only be the blue and black.
Okay, so
You won't
four,
use, yeah,
four of those coils will connect at the top, and then 2 of those will connect at the bottom.
yes, yeah.
That's what I wanted to understand. Okay, all right.
All right.
Thanks.
So there's our connections.
Thank you.
And now we get to our 10-way connector, which now tells us I've got 2 positive outputs, 2 positive out. I've got 2 negative, which is common. Then I've got I. What does I stand for?
IO.
Input. And an O will be an output.
Oh.
So you'll see I number 1, 2, and 3 can only be inputs because it's I1, I2, I3. So it's inputs. So example, if you want to hook up an external receiver, you will hook it up or connect it to IO to I1 or I2. Beams are default I3, but you can change it if you want to in programming. Then IO4 tells you it can be either input or it can be output. Depends on how you want to program it. Then you'll see 5 can also be an input output, but IO5's got a little bit bigger ampage rating than IO4, and obviously input 1 and 2 and 3. Then number 6 can only be an output. That's for your gate lock. So it can't be an input. You don't even think of putting a receiver into it. It's not going to do anything because it says, no, I can only be output. Okay? And IO or O6 is normally for your gate locks or mag locks. Okay, so you've got 6 channels. And channel 1, 2, and 3 can be inputs only. Channel 4 can be an input or output. Okay? Channel 5 can also be an input and an output, but it's got bigger or stronger ampage rating. And channel 6 can only be an output. Okay, so you've got a lot more flexibility than you had on the old V controllers.
So when to connect the cables of the older version and the newer version, is there difference?
Yes, you have to check your connections, what you have. If the client had external receiver, that 10-way connector, which is also a 10-way connector, won't match the 10-way connector on the new controller. So there you have to check your connections. What do you have? Oh, I've got beams. So the beam, safe close, is totally different from where it would be on IO3 and this one. So you would have to reconnect your beam connections. Your power can be your power into obviously positive, negative. So you definitely have to change your 10-way connection if you've got external receivers or external devices hooked up to it. If you've got a loop detector connected to it. Because here you've got FRX connection. Here you haven't got FRX because you can program any one of them to be a FRX. So you have to redo your connections on a 10-way connector to conform to the smart side of the VX. So the other connections, the motor connections are exactly the same. That 6-way and 6-way on the top and bottom, exactly the same if you had an old installation. But on the vantage VX, on the VX Smart, you have to redo your connections to make sure that you are connecting it to the right slot according to what you want to program this for. So it is not a 100% straight flip from old to new. You need to just reconnect or redo your connections on devices that were connected on the old installation if you had to. Okay, but it's quite easy. If you see it's beams, you took it out of beams, so you say, okay, default it's IO3 or I3. So where it goes into beam, safe close, you just take it out and just put it to 3 and just make sure you power it correctly. So it's not difficult to change over from old to new. It's just you need to physically look at it and say, okay, I need to take this wire out of the old 10-way connector and put it into this new slot.
Okay. So we can say on the new on this new thing that you added other options, right?
We did. Because how many times did you use a light circuit on the Vantage? Not often did you put lights on it.
Yeah.
How often did you put loop? Maybe you didn't put a loop, you did a beam on it. So we said instead of sacrificing cast in stone, trigger, pedestrian, beams, FRX and light, that limits your possibility that you can do with this motors. And I would say, okay, now you can program certain things on it. So instead of having a dedicated trigger, I can make I1, I can make it my opening beams and not a trigger. I can make my IO5, I can make it my closing, my opening beams, but IO3 my closing beams. I can program, obviously 6 can only be an output and 1, 2, 3 can only be inputs. So I am limited to what I can program them, but I've got a lot more flexibility than I had with the old V controllers. Because a lot of things you never used on them, because you never used pillar light, you never used loop detector, or maybe not even solenoid or something. So you've got a lot more flexibility on the vantage smart that you didn't have on the old one. Okay. So there's my 2 positives and my 2 negatives. Common, which is negative. Alright, and it's 12 volt now. Then we've got I1, 2, 3, which is input 1, 2, 3. They are inputs only. Then 4 and 5 can be inputs or outputs. Alright? And then my O, which is an output, 6 can only be an output. So default it is I1 is the trigger, I2 is pedestrian trigger, I3 is safety beams, closing, 4 is gate status, that's the output, 5 I think is FRX, and 6 is gate lock. But it can change if you want to. If you don't want to change it, it's there ready programmed for you, it's ready to be used. But you can change if you want to. Alright, there's our channels. So if I've got a push button in my house.
Before you go forward, just a few basic questions.
Yeah.
The COM, that's the common, right?
COM is common, yes, that's negative basically. Yeah.
Is it the common for the inputs and the outputs? For the inputs?
Yes, and for the outputs if you.
And for the outputs.
Yeah, well, if you obviously let's say you want to trigger a receiver, so you need to give it. We want to trigger a receiver to switch on a light or to give a power to a gate lock. That obviously that positive, that receiver or that positive gate lock's got to be on this positive because we always give a negative out. All our outputs, and I mean all of them except maybe 4. I'll get to that now. All our outputs. If you program an output on the Centurion product, 9 out of 10 times is normally, will definitely be a normally open circuit. So the one side of the connector will have 2 little connectors in that device. This is a polar phone. So you'll have one cable or one connector will go to I3 or 2 or 1, but default 1 is ready to open the gate fully. If you want this push button to open the gate pedestrian, you will connect it to IO2 or to I2 because they will be pedestrian by default, but you can change it if you want to in programming. So they're not showing it another cable because there needs to be another cable going to common. Because our input, we are waiting for a negative to come into the controller to trigger it. So if there's a common, this common will go through and will wait there because it's a normally open circuit. So that negative will wait there. Till I press the button. When I press a button, I'm basically creating a little short, a little breach, and then that negative will be able to jump through and come back into the input and say open. So there will be a flow of negative current, if I can say that, or negative power going through here. The moment I keep the button pressed in, the moment I leave my finger away, the little bridge falls away and the circuit will stop there. That negative will be waiting there, waiting for me to press the button. If I press a button, it goes through to I input, number 1. Then if I've got beams.
And where would the positive be from?
No, so we don't need, this thing doesn't need power. Well, it needs power, but maybe you get this could be a normal comb little push button. Or like this button. This button here is purely just 2 little circuits. One is negative and one goes to this input that chunks this controller to give an output. So this is just an all push button, which is basically that button. So normally open circuit, when you press it, you're closing the circuit. So, but it needs a negative to go into the I1.
It's just 2 core cable.
It's a 2-core cable. Yes, it's a 2-core cable. Indirectly. If you've got beams, so obviously you need power for beams, and it's hardwired beams, then obviously you'll have them normally closed, because beams are safety, so it's got to be a closed circuit. So you'll have your normally closed from your beam into I3. By default it's 3, but you can make it 1 or 2 if you want to. You can make it I5 if you've got opening beams You can have your closing beams in 3 and you have your opening beams on 5. So it all depends on how you connect it and what you have that you want to be able to work. Okay. You guys understand a push button, which is normally open circuit, going to I1, 2 or 3 or 5 or 4, depends on your programming, and then your safety, which will be a closed circuit, either open or safe open or safe close, will go by default into I3. But you can change it to any one of the inputs that can handle the input.
So that intercom system is the polo.
This one's a polar, yes.
Yeah, what if we are using the other ones?
Doesn't matter.
The
But
the Comex, what?
yes, so like who said it was a 2-core? You said it was 2-core.
Yeah.
So yeah, so if it's a polar phone or comb or whatever circuit or just a push button, it's normally open as 2 wires coming from here. One is coming from common and it sits there, and then the moment you press a button, the return goes basically into I1. So it's just a 2-core. So one gets a negative to the button, it's waiting till I press the button, then it goes back to, okay, there's a command, I got it, I'm closing this little bridge between a normally open, I'm closing it now because someone's pressing the button, then that negative from the common can go through into I1 or 2.
And the Comex normally.
Same, they've got normally open circuits.
It needs
Yeah.
the power.
Sorry?
It needs to be plugged.
Yeah, so if the intercom you're using needs to have power, you can power it from the positive negative from this unit, or maybe you've got a power supply in the house.
Okay.
If it's got power supply in the house, then you only need that 2 cables, the common and the normally open going to common and obviously your I1. If you need power, then you need a 4-core maybe.
Yeah.
But now you need to say, what is my distance from here to the gate? Could be 40 meters. Now you're going to start having voltage drop. If this polar phone needs to get power from the controller, and you're using normal comms cable, you don't want to run more than 20 meters because now you're going to start having voltage drop, and that's another kettle of fish. So we're just illustrating here that you can have a push button in your house, and via 2 wires you can now connect or command your gate from your house.
Okay.
Then we've got LED status. So like I said before, you need to default, only IO4 can be LED status for gate status indication. Okay? What does this tell you? The gate status or this LED status, what does it tell you?
The conditions of the gate. Whether it's
Yes.
closing,
Yes,
opening.
yes, yes. So we monitor with one cable, with one little small cable from IO4 to a LED on your Polo phone or on a G Ultra. We are monitoring a lot of things. Gate closed, obviously. Gate opening, gate open. Gate closing. Then we monitor pillar light on off. We monitor AC fail and restore, obviously. Low battery and restore. Collision and restore. And hardware fail and restore. So with one cable, we're monitoring 12 conditions. Actually 14 if you hook it up to an Ultra, because now we can tell you gate standing open. But if you keep it simple to LED, we are monitoring 12 different conditions on your gate. Because what happens, if the gate is closed, the LED is off. If the gate is busy opening, your LED is flashing slowly. If the gate is open, the LED is on. Okay? If the gate is closing, it flashes faster. And then again, if the gate is closed, the LED is off. AC fail will be 2 flashes and a pause. 2 flashes and a pause. It tells you it's AC fail. 3 flashes and a pause will tell you it's low battery. 4 flashes and a pause, and again 4 flashes and a pause will tell you it's collision. And 5 flashes and a pause will tell you it's hardware fail. So there's one cable we monitor on the LED. We monitor 12 different conditions. If you hook this up IO4 to IO4 on the G Ultra, which is our GSM device, we're monitoring 14 conditions on your gate. Okay. So, yeah, some other question? No.
So, before you go further, I wanted to ask, so on this modern thing, we are actually working now with signals. You can't see anything like the mass.
1, 2, 3, IO4, IO5, which is stronger, and you've got an O6, which is the output. So your channels is also known as IO. So if we talk, so it could be important for something's going to happen later on. So if we tell you how many channels do you have, we are telling you how many IOs do you have, which is 6 basically. All right. And then I is an input, example a trigger, and an O is the output. And as the input is the trigger button that goes into IO1 from your intercom example. You've got an O is for output, for example LED. So IO4 can be an O, which is output, and that is for gate status. So look at now, there's the flashing. You see, it is flashing, telling me the gate's probably closing because it was flashing fast. So that one cable from this LED goes into IO4. So IO4 is, we're using the O of the IO, we're using the O to be an output for gate status.
But by default, what is terminal 4 and 5? Are they?
So then, like I said, are normally used for inputs, for triggers. Then you've got your outputs, such as LED, could be a IO4, but that's LED, so it doesn't need more than 100 milliamps of current to push out. And then the last two channels, IO5 and O6, has got a 3 amp current limit rating. So that can pull in a mag lock or a gate lock, depends on what you have, or a relay to switch on your pillar lights. Okay, and they can handle 3 amps for 10-second pulse. And then the continuous rating on those two channels are 100 milliamps. So if you want them to be constantly giving outputs permanently, they can do 100 milliamps. So if you want to switch on a light, like 220 volt lights, you're going to need to use IO5 or IO6, and then you use it through a relay. So the IO5, for example, will pull in the relay. So the negative of that relay will go to IO5. The positive relay will go to 12 volt positive. So the moment you tell the controller tells the relay switch on by pulling it, by giving it a negative, the relay will pull in, and then your common normally open will become closed, and will switch on the lights. Okay, or depends on what you connect to it. And like I said, 5 and 6 are normally rated or used as outputs. Example for gate lock or for pillar lights, what do you want to connect to it. And now, here are the default settings of the IOs, what you've asked.
Yes.
So IO1, or I is 1 is trigger, 2 is pedestrian, 3 is beams, closing, RBC, closing beam. IO5 is default gate status. IO4 is gate status. IO5 is safety beams, opening, or FRX. So it depends on, so it could be FRX or opening, depends on, the first ones were FRX, this one, the new ones are on opening, RBO for opening. And then 6 is only output and is for gate lock. Alright, any questions regarding the default triggers? No, it's not safe to open because you are too close to the beam or to the gate opening, but the gate will be in its full opening position. So it will be good to have 3 beams. 2 will be in series on the closing side for the safe to close. And then you have the third beam will be also a closed circuit, will be on RBO. So it's saying it's not safe to open, or it is safe to open, depends on if it's broken or not. So this is illustration.
Can you basically illustrate this on the
Yes.
board as to where physically you put those beams?
Correct. So here we've got I5, so the transmitter and receiver needs power, but it's a closing beam. Here we've got our opening beam, again I5, transmitter and receiver. So what happens is the normally close of the closing beam goes to default I3, which is default my closing beam, IRBC, closing. My opening beam, default, if it's not FRX, IO5 will be my IRBO for opening beam. But it's got to be a normally closed circuit, it's a safety, so safety's got to be a closed circuit. Alright, so there's my connection. I'm going to do the power now, but your closing beam default, it's 3, but you can make it 2 if you want to. So your program that if you don't want to program it, then you use I3 because it's default there already for you. On the opening, you use I5, IO5, but you're not using it as an input. Then obviously you've got to give them power. The transmitter and receiver needs to get 12 volt power. Yes, 12 volt power. You see the power going through. Okay. Then your negative you can breach up with common, and that goes to your common. And now we're doing something very strange. What is this? Now we are taking the negative of the transmitter, we are taking it to IO4. For what is that? Who can tell me, except Murray?
Beam checking first.
Yes, 100%. It's your beam test or beam common. So if you do this, if you program, but now default IO5 is not programmed to be beam common. You've got to now program IO4 to be a beam test or beam common. So why would we do this? Who can tell me why would we do this? Beam test. It actually explains what it is. But what is beam test? What the motor does, yes? What do you think it is?
Those set of beams
Yeah?
must always detect each other.
Um,
The receiver and the
Yes.
transmitter.
yes. Yes,
So-
yes, yes.
Actually, we want to see always
Always.
that they are working.
Yes, correct. Yeah, so the moment if I'm now a person or a car, and I get in between the transmitter, because the transmitter, it says, I'm here, I'm here, I'm here, I'm here, I'm here. And the receiver is saying, okay, thank you, I've got you. So if I've got you, if I see you, I'll be closing, and I can get a close signal to the controller is happy. The moment a person or a car stands in between the transmitter and the receiver, it says, then the receiver says, where are you? I don't see you. If I don't see you, I'm going to open this closed circuit, I'm going to open it, and then it tells the controller it's not safe to close, or it's not safe to open. It depends on where it's connected. So there's got to be constant signal, the transmitter saying, I'm here, I'm here, I'm here. This one says, thank you, I'm closed then. If I don't see you, I'm open. So if it's me standing here between a transmitter receiver or a car, that will then stop the signal being transmitted. Or if this transmitter loses power, obviously if it's got no power, it can't say, I'm here, I'm here, I'm here, because it's dead. So this is what we're doing. If you do beam test like this, in normal operation, this IO4 is always giving a negative out to the transmitters. So they can tell the receiver, I'm here, I'm here, I'm here. But when you press a millisecond before you do press a button for the gate to open or close, it does a test. It takes away the power for a millisecond just before it opens. IO4 in this situation will take away the power, will stop the power from there. So that means this transmitter will lose power. If it loses power, then the receiver will say, hey, I don't see you. And then the moment for that millisecond, it will tell the controller, I haven't seen this transmitter for a millisecond. If the controller sees that there was a break in communication, it says, okay, then I know you are working. Because for a millisecond, you were working, you were close. For a millisecond, I took away the power. So I had to see an open circuit for a millisecond and then give you power back, and you have to close again. Then I know your operations, you are good. Because let's say there's a short between, if I breach a wire here, doesn't matter if this transmitter loses power, doesn't matter if this receiver loses power, I have breached out the circuit somewhere here. So I will always have a closed circuit on my controller. So when you do beam test and you take away the power, but the circuit didn't open for that millisecond, the controller says, hang on, wait. I took away power of this transmitter. So I must have received an open circuit for, only if it's for a millisecond. If I didn't receive it, that tells me there's a short somewhere on your cable. Because I'm still seeing a closed circuit.